All right, Jared, what are we working on?
Number 3 is the one that says first. Wait, this is not the right chapter. Okay. That looks
Okay.
right. Number 3.
All right, so find the first and second derivative. So, what do you know about the first derivative? How do you usually find it?
But the highest one? No, I don't know.
That's okay. All right, so it's exactly what it sounds like. First derivative is you take the derivative the first time. Second derivative is you take it twice.
I don't know what that means.
Okay, that's fine.
I don't know a lot of what I'm doing.
Okay, so earlier, in earlier sections when you were working with the precise limit definition that I showed you a little bit ago,
Yeah.
that's taking the derivative one time. So then you get a big jumbled mess of what your derivative is, right? You can do that again to that, and that's your second derivative. We'll show you in this example, but first let's just focus on finding the first derivative, right? It's not harder than it sounds, just find the derivative. So you're working on number 3, right? S equals 5t cubed minus 3t to the 5th. What do you know about taking the derivative of this?
I don't know.
That's okay. Do you know any rules that you guys have went over for derivatives? Probably the first thing you went over for derivatives before you did the quotient rule and the product rule. Okay, let's look back in your book and see if we can find some. So here's the product rule. Are we using a product here?
No.
Right, so that one's probably not going to help. Alright, so we have powers here, right?
Mm-hmm.
So the nice thing about this, since they're not multiplied together, you can split them up. So first let's just deal with the first part. Could you tell me how to take the derivative of this?
Probably not.
Okay, so out of these rules, do you see any of the rules here that might be able to help you?
Or is this the, like, n times t, and then there's like n minus 1 on for the exponent?
Yeah, exactly. This one right here. That's called the power rule.
Is that what we're doing right here?
Yeah, it's really important because you're going to use the power rule forever when you're taking your derivatives. Almost every time you'll use the power rule.
So then that's 3t squared, right?
But we have this 5 in here.
Oh.
Okay, so you have it right. If we were taking the derivative of t cubed, that would be 3t squared. You take the power to the front, multiply it, subtract the exponent. Okay, so if we were to do that with 5t cubed, what do we do?
3 times 5?
You got it. And what should the exponent be? Can you simplify?
15t?
Okay. So that is the derivative of this part, right?
Mm-hmm.
So I'm going to write that over here so we don't forget it. Now we got to take the derivative of the second part. So we have minus 3t to the 5th.
It's 15t to the 4th.
Perfect. You're missing one little thing. Can you find what it is?
Negative.
Yep, don't forget that. That's really important. So if you put them together, this is your derivative.
So that's the first derivative?
Mm-hmm. Because these aren't multiplied together or divided, you can split them. If they're added or subtracted, you can do it piece by piece like that. That's why when they are multiplied or divided, you have special rules that you're learning now, like the quotient rule and things like that. Okay? So this is this the first derivative or the second derivative? Okay? So this is our first derivative. You'll often see it written like this, like f prime.
Is this math 102 or?
Does this make sense how we got to here?
Yeah.
When you're working with derivatives, you have a lot of rules. And I know rules aren't fun, but I promise by the end of this class, they will be drilled into your brain and you will never forget them. All right, so this is our first derivative. How do you think we get our second derivative?
Do the same thing again on that.
On that, right. So can you tell me what it is?
30t minus 60t cubed.
Perfect. That's all it is. And you can, and that's written f double prime, so just 2 apostrophes. And you can go do this as many times as you want. Eventually, you'll get to where you can't take the derivative anymore. But that's how you do the first and second derivative.
Okay.
Okay? All right, so let's see. Let's try the next. Have you tried the next one on your own? See if you can get there. So what number do you have?
7.
All right, perfect. So what's going to be your first step?
The derivative of the first one?
Yep.
Which is negative 6z to the negative third.
Perfect. Yep, be careful when your exponents are negatives, because when you subtract one, oftentimes people will say it's -1. When you subtract one, it goes down.
I about said that
Yeah.
too.
Yeah, just be really careful. I still make that mistake sometimes. So. Okay, so that's the first part, right? Okay, what's the second part?
I don't know.
So we have -1 over z. Just think about that for a second. Do you know a different way we can write that? Or a way that can make it easier for us to take the derivative of?
Z to the negative 1.
Perfect. Now do you know how to take the derivative?
So then this will be z to the negative 2. Positive z, right?
Yep.
Okay.
Why is it positive?
Because -1 times negative z is a positive.
You got
Double
it.
negative. Okay. Next part's easy then.
Is this starting to make more sense, Jared?
Yeah.
Good. Good.
Definitely more sense.
See you there.
I forgot things.
Very brushed up and ready.
Right.
So, real quick, let's look at that 7 again. The
Okay.
first part of 7. I think you missed one little thing in there. Can you find what it is?
Uh-oh. This is negative, isn't it?
You got it.
Okay.
That will change your answer for that one. Yeah. Perfect.
Alright, sweet. So then for number 11, do you want to make the exponent negative to get the derivative for that one?
Okay, so let's look at your 7 part 2 again.
Okay.
So how did you get the derivative of the first part?
Like with
You're
this
not
one or
wrong.
this
Just
one?
explain how to do it.
Uh-oh.
That's okay.
Forgetting the first derivative or the second?
Yeah, to find the second derivative, what did you do?
Took the negative 3 times the negative 6.
And what did you do to the exponents? Subtracted one, right?
Subtracted 1, yeah.
Okay, so how'd you do the second part? Yep. So you had z to the negative second.
Yes.
So you brought the negative 2 in front times z. What should your power be?
1.
So you subtract 1 always, right?
Oh, wait. Shoot. Negative 3.
Yeah.
Whoops.
Yep, just be really careful when you have negative exponents again.
Yeah. Yeah. I got everything right this time now, right?
You tell me? Are you confident in it?
Yes. Yeah.
You should
Yeah.
be. Yeah.
Okay.
Yep, don't second guess yourself. I'm just making sure you understand exponents good and everything.
Yeah. Okay, then for that, do I make the exponent negative again? So this would be, or would it be the full thing negative? I don't know. I'm confused.
That's okay.
I'm confusing myself now.
So let's not think about that example. Let's think of this example, which is completely different, right? So if I have 1 over 4r to the 5th, Would you agree that that's the same as 1/4 times 1 over r to the 5th?
Yes.
Yeah, they're the same thing, right? So how can we rewrite 1 over r to the 5th?
Negative fifth.
Would you be able to take your derivative of this?
Yes.
Okay, so now, going back to that example, if we have 1 over 3s squared,
So then I split it up front. So it's 1/3 times, what is that? Times s to the negative second.
yeah, you can write it like that.
Is that all that I got to do with that one then, or do I got to do?
You still have to take the derivative. This is just putting it in a different form. It's hard to see when it's the variables in the denominator. That's why we always bring it out. Because then you can use the product rule that we've been using.
So this will be 5 over 2 times s to the negative 1. Which is gonna
Okay, double check yourself one more time. So in the power rule, you bring the power to the front, right? So you have, if we started with 1/3 s squared to the negative second, sorry. How do I take the derivative? Explain to me how to do it.
I gotta, what is it? I think the 2 times the denominator to find the number in the numerator, right?
So you
Or-
bring your power rule, which is the one that we just used. Right there. What does that tell you to do?
Take the exponent times the number, I don't know.
That's okay. So let's think of it in general, right? So if we have x to the n, what the power rule tells you, Jared, is that the derivative of x to the n is n x to the n minus 1. All that's saying, I know it looks really like confusing in fancy math terms, it says you bring the n to the front and you make the power 1 less. That's all the derivative is. So in our example, let me write this over here. So, in our example, if we have, is it 1/3 s to the negative second?
Yes.
How do we do this? Using what I just switched here.
So I'll just bring the negative 2 in front of the 1/3 and s to the negative third.
Okay, so if I simplify this, what should I get?
Negatives, no. Yeah, negative 7 over 3, I think.
How are you getting a 7?
So it's is it 2/3?
Yep. When you multiply fractions, so this is 2 over 1 times 1 over 3, it's just you multiply straight across. So 2 times 1 is 2,
Yeah.
1 times 3 is 3.
I remember that now. So then it's negative 2/3 x to the negative 3.
You got it? Okay, you want to double check yourself on the second part, just make sure you got it?
I think it's right. Yeah.
Are you confident in it?
Yes.
Good. got the pages on next to it.
It's alright. So then,
Good. Is it making more sense now?
yeah.
Good, good. Yep, as long as you know this, and I don't even remember it like this, I just remember bringing the power in front and taking it -1. That helps me, so.
Okay.
Perfect, so power rule, better now?
A lot better.
Good, good. That's really good.
And number 17. Hopefully. This is where she lost me.
Alright, so now we have more than just addition and subtraction, so you can't split it, right? So there's another rule that we can use that has to do with division. Do you know what rule that is? Yep. Do you know what the quotient rule is?
I remember it's like 7. So f prime times g minus g, or f times g prime, I think.
Alright, let's look back though and just make sure. Alright, so missed one little part. You can always go back and find these. Here's the product rule, the exponential function, derivative of the quotient rule. They're all in the book, right? This one looks a little bit more complicated. It's saying the exact same thing as what you just told me. It just uses the du dv instead of f prime and g. Okay, so before you even look at this, we need to talk about how to split this up, right? So when you're working with the quotient rule, you have, I'm going to call it triangle, some messy function up there, and circle, some messy function down there, right? A lot of people, when they're working with the quotient rule, try to split it up really hard. It's actually pretty simple. It's just your top function is always f, the bottom function is always g. Okay, are you okay with the f prime and g prime?
Probably.
So that's what we just did, just taking the derivative.
Oh, so that.
So this is the derivative of your top function
So then,
times the bottom function minus the top function times the derivative of the bottom function.
I'm a little lost.
That's okay. Well, here, let me make up an example. So if we
is
had,
f prime the derivative of f then?
Yeah.
Okay.
so if we had 2x plus 3 over 4x squared minus 1. Okay? This is f, and this is g. Okay? So let's work this through piece by piece. F prime times g. Well, first you gotta know what f prime is, right? I only told you what f is. Can you tell me what f prime is?
So do I have to take the derivative of the whole function, or is it just the
Just the
2f?
top part.
Okay. Is it 2x not 0? 2x is 0?
Okay, so this is the same as 2x to the first, right?
Yes.
So using the rule we just went over, how do we find the derivative of that?
And then take the 1 minus 1, so it's 0.
2x to the 0, right? X to the 0 is what?
I know she said this. Is it 1?
It's 1. Yeah, anything to the 0th power, it doesn't matter if it's a million, anything to the 0th power is 1. So you can just get rid of it. Okay, so what's the derivative of f?
2.
Got it.
So I don't have to do anything with the 3 then?
Okay. That makes sense. Technically, you do, but when you're working it through in your mind, you can kind of just disregard the 3.
Okay.
So technically, a 3 is the same thing as 3x to the 0.
Oh, okay.
You pull the 0 in front, 0 times 3 is 0. So it just disappears.
Okay.
Does that make sense?
Yes.
Okay. So that's f prime is 2. Well, we know later on we're going to need g prime. Right? So what is g prime?
Okay, so G prime. Bring a 2 up front, so it's 8x to the first.
You got it. All right. So now that we know everything we need to know, keep in mind this isn't the same problem that you're doing.
Oh, wait.
Yeah, this is just an example problem to help you understand.
Okay, yeah. Sorry, I forgot.
Okay. So now that we know everything we need to know, we can start plugging in. Okay. So your first thing is f prime times g.
So then that's 2 times 4x squared minus 1.
Perfect. Minus,
Okay.
and then you have f
2x plus 3
times g prime, sorry, times 8x. Sorry, that's a little messy there. All over g squared. What's g squared?
8x. No. Uh, 4x squared minus 1 squared.
Then from there, you just do a bunch of simplifications. Does that help you with how to set things up? Does that explain the f prime a lot? Good,
Yeah.
good. Okay, so now
I had to ask, right? Because I asked me just how to get the 1 out front.
Yep.
She didn't explain it to the way that I
Yeah,
understood
yeah,
it.
no problem. So as long as you can get your f prime and your g prime, then you can set it up. Okay, so let's go back to your problem now. Hey Steph, how's it going? So if we have 2x plus 5 over 3x minus 2, which function is f?
Top one.
Okay, so what would f prime be?
2.
Perfect.
And then g prime is just 3.
You want some clarification on that? You sound a little unsure as to why this one's just 3.
It's because it's like 3x 0, which is a 1. So I get
3x
rid of
to
the
the
x.
first. Yep.
And it's just 3. Okay, so then. Right?
So you did
F
f prime, which is 2 times g
F times g
prime. Good. All of
g
those.
squared.
Yeah. Okay, and then you just got to do a lot of simplifications, right?
Mhm.
Are you comfortable with doing the simplifications?
Yeah.
Okay.
Pretty confidently anyway. So 6x's on top cancel out, right?
Yes. 6x minus 6x is 0. Let's check one thing on your top. I think you missed something when you pulled this negative through. Just check what that is.
Oh, is it a negative 15?
Yeah, so when you have parentheses, the negative distributes to everything inside the
Oh,
parentheses.
yeah, okay. So then that's negative. So then, do I simplify further than this, or is that it?
I don't think you can. No, I think that's as simple as it gets.
Okay. Nice.
Good. You seem more confident in that. Here.
Yeah.
And that will help a lot now that you understand that when you're doing the product rule too, because you still have the f primes and the g's in that product rule too.
I didn't know how to find the primes. I didn't know what they were.
Yeah, that's just saying the derivative of that.
Okay.